In this video, we are working with the factorized form of a quadratic function. The first thing we want to notice is that it's not always possible to write a quadratic function in factorized form. For instance, let's write an example here. If we consider the function f of x equals x squared plus 1, we know that we are not able to factorize this expression x squared plus 1 if we only use real numbers. So this will be a case where we cannot consider the factorized form. But we are going to focus now on those cases where we can factorize the quadratic function. So here, let's write can't factorize on R. We can do it with the complex numbers. And now we are just going to assume f of x equals ax squared plus bx plus c can be written as f of x a times x minus b times x minus q. So assume we can factorize and these p and q are real numbers. To factorize it, we can use any of the techniques that we have practiced earlier, splitting the middle term. You can use the quadratic formula, whichever way you want, but we just achieve to do that. So once we make sure that we can do that, I want to look at the 5 main features of the graph of our quadratic function. The first thing that we are going to write here is the concavity. And that's as usual given by a. It's going to be the coefficient of the leading term. If a is greater than 0, the concavity is positive, and if a is less than 0, the concavity is negative. So that's the first one of the features. The second one, and since we have the factorized form, is going to be the x-intercepts, because the x-intercepts are pretty much screaming at us. If we want to find the x-intercepts, what we want to know is for which values of x it's true that when we have a times x minus b times x minus q equals to 0. So for this to be true, we need x to be equals to p or x to be equals to q. So that means that the coordinates of the x-intercepts are going to be of the form p0 and q0. So they are the easiest to find when we have our quadratic function written on factorized form. The y-intercept is never hard to find, so let's write it here as well. What we want to know is what is the value of the function when x is 0. So in this case it would be a times minus p times minus q. So this is apq. So the coordinate is going to be 0 apq for the point of the y-intercept of our function. Now, if we want to find the axis of symmetry, we know that the axis of symmetry is on the picture here, halfway between the x-intercepts of the function. Yeah, because I need to make sure that when I fall through the axis of symmetry, the two x-intercepts coincide. So it has to be halfway between them. So I need to find the point that is halfway, so the midpoint of the x-intercepts p0 and q0. So that's going to be at the point p plus q divided by 2, 0. So the axis of symmetry is going to go through that point, and it's a vertical line. So it has equation x equals p plus q divided by 2. And the last feature we need to find is the vertex. I didn't write here, we will find in the axis of symmetry. And remember, the axis of symmetry should be always written as an equation because it's a line. You can't answer just p plus q divided by 2 We're talking about a line, so you have to give the full equation of the line. X is equal to P plus Q, all divided by 2. Now, going back to the vertex, we know that the vertex is one point of the axis of symmetry, and it's a point of the function, of course. So we need to find what is the y-coordinate, because the x-coordinate is going to be P plus Q divided by 2. So we just need to evaluate our function at P plus Q divided by 2, and we'll have the coordinates of the vertex. Let me add something. Everywhere here we are assuming that A is not 0. If A is 0, well, then we don't have a quadratic function in factorized form to work